so you got a
okay.
you get that.
We have a backup just in case we need it. Yep. Okay, the webinar is setting up. We are redirecting, and I'm going to need to mute this right away. Okay, we're good. And then what we'll do, Pete, is any questions that come up on YouTube, I'll go ahead and do that. I see Jonathan Lightfoot is on. He said good morning to everybody. Pete, you'll be able to see the chat at the bottom, and then there's also a Q&A. And but I'll monitor that for you, and
appreciate it,
and let you know if a question pops up. Would you prefer to get through the whole record or the whole presentation and then take questions, or should I go ahead and interrupt you?
I think if you want to introduce me, then I'll go through the presentation, then we'll take questions at the end.
Okay, we'll take questions at the end. That's fine.
Yeah.
We can just queue them up. So, all right, good. Well, everybody, welcome to IDD webinar. We have the pleasure of having Mr. Pete Clark on with us today. Pete's with Chevron, and it's been 10 years or so, hasn't it, Pete, that you've been there? Yeah.
Yes.
Yeah. You started when you were 16, right?
A little younger than that.
Okay. All right. Well, we won't give away your age. Although I see Neil Bergstrom's on, so he can probably do the math and let everybody know what that is. But Pete's done a great job at Chevron. They've would put them at the forefront of a lot of the directional things that they're doing on a wide range of things. So without further ado, we'll go ahead and allow Pete to go ahead. And Pete, you can share your screen, and you're ready to go. If you have anything else to say as an intro, just go ahead and pop in there.
I appreciate it. So bear with me while I find my presentation. Bear with me. Old man technology, it's not a great mix. So hopefully you are now seeing introduction slide titled Autonomous Geosteering, which is a little bit greater than the title's a little bit greater than the proposal. And it is just
it hasn't popped up yet, Pete.
Oh, has not?
Uh-huh.
Oh, I wonder what I've done wrong.
I think no.
I am seeing a blue boundary which says which infers that
there you go. It's starting to share screen now.
Okay.
Okay, but you got the wrong one. You got your email up.
Yeah. Refer back to the first comment, which was old man and technology is not
there you go. You have succeeded.
Okay.
We'll give you the benefit of the doubt that was intentional and you just didn't happen to blunder upon the right thing. How's that?
Very kind.
Okay. Take it away, Pete.
Thanks. So you'll see the first slide. It's titled Autonomous Geosteering. That's perhaps a little bit of a stretch, but some form of automation. And what we're going to talk about today is really in terms of a proposal. It's an idea. So as we go through this presentation, you'll find that the slides are intended to be informational, and Jim's kindly agreed that you'll put them on the website, so they'll be available. What I say and what's on the slides, we'll try and keep them roughly in sync, but we try to put some information out there. So the first few slides we'll kind of talk to what we're trying to do, what we see as an issue, and what we would what the opportunity and what's there, what could be improved, and then we'll go on to describe the potential method, and we'll talk to some of the limitations of it. So this is Colorado in Labor Day of last year, and you can see a muddy road. I was coming down this road on a bicycle, and felt it was a good analogy for what we're doing with some of our unconventional drilling. I had a bank on my left-hand side that I didn't want to hit. I had a barrier on my right-hand side, and I really didn't want to hit it. Better than that is the barrier is evidently and obviously concrete, and I believe that concrete has some limestone in it. So if we imagine that the roadway is the shale that we want to drill, then we've got a limestone stringer below us, which we really don't want to tag. So that's the analogy. We're trying to stay on the road with our drilling assembly, and we're trying to drill shale. So much the same. We have this planned trajectory in blue. We have the black band, which is the limestone stringer. In this case, it's shown as being continuous. And without meaning to take anything away from our geosteering colleagues, occasionally we're challenged and we're not able to stay in the shale. And we may, as shown, intersect the limestone. In this case, we've intersected the limestone on 4 occasions. And the picture below is really just the same picture as you saw earlier. It's just been turned on its side and stretched, but it's the same. And I'm just using that as an analogy. We've got concrete below us. We've got the limestone boundary that we want to avoid. And the reason that we want to stay away from the limestone is we see much higher vibration when we tag up on the limestone, and we think that that's affecting the reliability of the equipment that we have downhole. So my argument is one of wishing to improve our reliability, and if this also improves our wellbore placement, then that's great. When we talk to wellbore placement, one of the phenomena that we've observed, and we suspect that others have observed, is a roll right, lever left tendency when we tag up on harder objects, harder layers, such as the limestone. What we really want to do is just drill bed parallel. What we see is if we're coming at it from above, and that's what we're showing on the left-hand side. If we come to this hard layer from above, then what tends to happen is we deflect, the inclination comes up on us, but to a greater extent, to an even greater extent than the change in inclination, we have this roll off to the right. And you can explain that in a few ways. An easy way to explain it might be that the cutters on the bit are digging in and causing the assembly to move to the right. Whether that's the physical phenomena or not can be debated, but certainly what we observe is that if we come at this from above, we see a roll to the right. Conversely, if we tag up on it from below, we see the inclination get pushed down relative to where it was, and we see the azimuth go to the left. We'll call that lever left. So roll right, lever left. By way of evidence, I've got the plot that's in the center. To get this, to be allowed to present this, I had to avoid showing any chevron information. So I used somebody else's information, and this was actually a set of data that Jonathan Lightfoot shared with me, and it's really quite interesting. So there's it's public data. And all I've done is I've taken the survey information, and these are only the surveys that are in the lateral, and I've calculated the dogleg severity, and I've calculated the resultant tool face. So the resultant tool face is the tool face that you'd need to go from one survey station to the next survey station. And I'm going to try and persuade you that the red dotted line is the trend that we're seeing throughout that data. So all the way along that lateral, we have been tending to go up and to the right or down and to the left. And that's what essentially we've been talking about. We've been talking about rolling right and levering left. And this is common in data sets. Widely spaced data, 90-foot surveys don't show this as well as some other data sets, but you may well notice this in data that you have. Okay, I can show that, and really I'm just having fun showing it in a different way. Same data set, same well. In this case, we have a circle in gray, which is a 1 degree of incidence. So if you imagine there's a theoretical straight line goes from the first survey in the heel all the way to the toe, you can draw that theoretical straight line, and then you can calculate the incidence angle, which goes between the actual well path and the theoretical line. What you'd like is that you stay in the center, that there's absolutely no movement from the center whatsoever. That would be a perfectly straight well path. So in some ways, what you're seeing is a measure of straightness. And again, you can see that there's a strong up and to the right, down and to the left trend. We're effectively being pushed one way and the other, and we're reacting back to get back onto the line. I will say that this is still fairly good performance, that it is still a fairly straight well. You can see that the majority is within 1 degree of incidence of what the straight line is. So with that, what we talked about is the objective is really to drill bed parallel. The issue is that much as we'd like to follow a straight line with a hold inclination function and a hold azimuth function, much as we'd like to follow that straight line, the boundary layers are going to drive our directional performance. They're going to move us in different ways, and we often hear that from the directional drilling business partner as formation push. And the opportunity, I believe, is that we could improve the steering logic in a way that avoids us intersecting the boundary layers and indeed has us drilling bed parallel. So how might we do this? Well, the first thing on this slide that I need to do is to apologize. And I'm going to apologize for the sketch that's on the right-hand side. That's meant to be a gamma log. It obviously isn't, but it's meant to be a simple drawing of gamma. And in this case, we've identified target A and target B. And really, I just did that so I could draw black lines over the points that were most egregiously wrong. It is just a squiggly line, but it's meant to represent the gamma log. And what we think is that if we embedded the knowledge that we have of the gamma cross section, we'll call that the type log. If we embedded that into the rotary steerable tool, we would be able to modify the hold inclination mode. And that's really what we're hoping for, is some interest in an enhanced inclination hold mode. So instead of simply sampling the accelerometers and holding inclination, it would fold in the gamma ray information and modify that hold inclination. Okay, so in order to do this, we would need to have a contemporaneous, happening at the same time, gamma measurement, and we'd need to understand the gamma gradient. So it would have to, might not be an ASI gamma measurement, but at least an up-down gamma. So we have a rotary steerable with hold inclination coupled with up-down gamma. We think, because the information is somewhat noisy, that we think we may have to filter it out. The time-based measurements, so we think we're going to have to deal with some of the noise in order to detect a signal. The idea is really that an algorithm would work out the formation dip. So let's talk to that a little bit more. So the type log is our best guess of how the gamma lithology, the lithology is. And we think we can model that with a curve. We think using software applications such as MATLAB, we can model a relatively short interval, obviously not the whole gamma log, but if we chop down the TVD interval small enough, we think that we could model it with something like an 8th power. Higher powers would be better. So the higher the power, the better. Essentially, 8th power allows for only 7 up and downs. So we would have some ability to model that in a mathematical way. That would be in the downhole tool, and we would now be measuring where we were relative to the log and understanding the gradient that we expect. So we've not only got a target gamma value, but we're also looking at the gradient of the gamma value. We can see that if we've got an 8th power polynomial, or 8th power or higher, if we've got an 8th power polynomial, it's relatively easy to differentiate that to give ourselves another polynomial which would describe the gradient. So we've got a way of not only understanding the target value, but we've got a way of understanding the expected gradient. If we track that over time, we should be able to understand if we're going up or down in section. We should be able to understand where we are in this log and how we're doing. So it would be a case of monitor and reassess. And two ways of implementing it. We might apply a nudge where you simply realize that you're cutting down section and shift the inclination up. Or you might be cutting up section and shift the inclination down. And you might do that by an increment, a small increment. Or you can attempt to solve the analytic solution, assuming that ROP is being used as a proxy for the measured depth, because the gamma measurements will never be associated with measured depth. They'll be associated with time. So you need some way of understanding their depth arrangement. Okay, so as we move through, another point to make is as we move through this section, as we drill from our landing point out towards the toe, it's quite possible that the type log may be modified. As we drill it, we may feel that the type log's not a true rendering of what it is we're drilling. And with this system, with a polynomial, it'd be relatively easy to send that to downlink that to the tool. It's only a small amount of data to be sent to the tool to reconfigure what we understand the target gamma interval to look like. So kind of saying the same thing again, we've got an RSS with hold inclination. If it has hold azimuth, that's great. We've got some integrated, not necessarily azimuthal, but certainly up-down gamma. And we have an understanding of the target gamma interval. So the expectation is that it's available. It's of the necessary quality, and can be modeled in the way that you can fit a polynomial over that. I fully understand that may not describe all situations, and there's lots of intervals that we drill where we find that the geology is much more heterogeneous than I'm indicating as a requirement for this type of implementation. And again, it would require a fairly focused interval. You're going to be looking at a fairly small interval of gamma. So how does that look in a procedure sense? It's a little bit like the early cruise control. So what we might have is that we land the BHA in the target interval, just using our current procedures. And as you recognize where you are, so as you've got your car to the desired speed, you then downlink and set it in, I'm going to describe it as a modified hold inclination mode, and obviously the car would go into cruise control. As with cruise control, one of the things that we quite like about this proposal is that it is just an enhancement. If the feeling was that this, or the analysis was that this wasn't providing benefit, then another downlink could be sent, and we could take the tool out of enhanced hold inclination, and we simply return it to the hold inclination that we've been using in the past. So we would just put it back into the existing mode. We're not obliged to use this. We can use it when we believe it's helping, and we can disable it when it's of no assistance. This just talks to the gamma setup, and we've kind of talked to this already in some detail. So least squares best fit, using various software algorithms which are available in the market. You can see that that whatever polynomial is used to fit. I'm just showing that I still have a small command of math, and that I'm able to differentiate going from the left-hand side to the right-hand side. It's relatively simple to go from what we believe would be the target value, which is shown on the left-hand side, to what would be the expected gradients, which would be on the right-hand side. And as stated before, this is a small enough packet of information that we would expect that we could communicate it back down to the rotary steerable if needed. Okay. This is very much, and again, these are kind of informational slides. We've kind of talked to this as we've gone through the presentation. Essentially, I'm going to draw your eye to the diagram at the bottom, where various rotary steerable suppliers, they started with hold inclination, a closed loop hold inclination. We measured the value in the tool. It goes into a comparator. So there is something which compares the actual measurement with what our target value is. It then applies some control logic and hits the actuator to control it back to send it back to the target value. And occasionally the target value that's in the comparator can be changed. So that's a generic feedback loop. With the business partners have developed not just hold inclination, but they've also developed a hold azimuth. And really what I'm suggesting or hoping for or proposing is that we fold in the next measurement, which to my mind is gamma. So we would fold fold in inclination measurement, azimuth measurement, and gamma measurements all into some form of feedback loop and controller logic, which would then have an effect. Implementation, well, we've kind of talked to this. The idea is that we'd hope to drill bed parallel. If that was successful, perhaps there's circumstances where we could use it to land the well, or at least in the last portion, we could use it to land the well. That would be that would require a fairly homogeneous gamma gradient and be able to do that. As stated, we could drive it sequentially with a series of downlinks for a series of portions of gamma interval, if we like. So it doesn't have to be the same target throughout the lateral. It may be that we want to change where we are and in some way drive manually between the two, or give it a wider scope and use it to go between target intervals. Okay. Unknowns, limitations. Well, gamma, you can see that I'm suggesting modeling the gamma as a mathematical function. That's likely to only be successful over a very short interval. And even then, there's likely to be some scale factor effects. So there may be some requirement in the algorithm to understand bias and scale factor. The gamma has a noise, a chatter, and we would need to average the gamma in such a way that we were getting a good value to go into the algorithm, because the individual measurements are likely to have too much noise and send the feedback loop out of control. There may be some improvement can be done in terms of the up-down in order to determine the gamma gradient. The gradient could easily just be the difference between the two, or if we have a sectored gamma, it may weight some of the sectors in order to provide a more accurate understanding of gamma gradient. And then, as mentioned before, we might use time as a proxy for the along hole depth. That would need some understanding of ROP, and obviously if ROP is highly fluctuating, then it's going to be a poor use. With downlinking, it may be that ROP could be downlinked. Okay. And then we would also recognize that this is indeed, it's a lagging system. The measure of inclination may be close to the bit, the measure of azimuth may be proximate to that, but the measure of gamma is probably going to be some way behind. And in any lagging system with a feedback, we're going to want to try and control for that, because the measurements that you're making at the time don't reflect the situation at the bit. So acknowledging that is a limitation, and something to be considered. And then, as mentioned a couple of times already, the idea that the type log might change as we drill along the lateral. Things that would improve. Well, you've heard me mention downlinking a couple of times, and obviously, if we're able to downlink seamlessly and downlink in a faster way, so indeed sending the data by EM, we might be able to enhance this system if it were to work. And then there may be some other aspects, some of the parameters set up in the algorithm in terms of we're expecting some sort of filtering, we're expecting some sort of averaging over a period. And it may be that you would want to reset those parameters in the algorithm from time to time should they be seen to be working better. And I think that is it. So I very much appreciate your attention, and thanks for listening. I'm going to stop sharing and happily answer any questions if I can.
Okay. We have you can see the questions there in the bottom of the screen, Q&A.
I will open that.
There's one from Anon E. Mouse.
He gets it out.
Yeah. With systems that only count with up-down gamma rate in the MWD and not in the steering head, following the polynomial solution would be inefficient. With the first approach, a best option relying only in near-bit ink and azimuth trends to determine if we're bouncing up or down, and then modify the target ink to best align with the formation dip. That's a mouthful.
So, yeah, it is, and I'm going to start on the start of the question, which says that the up-down gamma ray is in the MWD and the steering head is not connected. And if that's your situation, if your steering head doesn't talk to your MWD, then you're in a world of hurt, and this is probably not going to work for you. But there's systems out there which have the steering head and the MWD connected and fully connected, and that is probably a better starting point than where you have those two disconnected. There may be some things that you can do if you have a disconnected system. There may be some things you can do. Hopefully that answers that question.
Well, I think the second part of that really is being able to monitor formation trends, at the bit, and then responding to them. In other words, if it's pushing you left, right, as you indicated earlier, right, you saw that range of responses and so forth. So using that to stay on the road, as it were.
Yeah. So let's build on that point. So I suggested that the trend to go right was because you're hitting a formation from above. You're hitting a hard formation from above, and I suggested that the trend to go left was because you're hitting a hard formation from below. And it may be that the questioner is suggesting that those could be used as a proxy, and I would agree. Whether they would be effective proxies, I don't know. But it may be that because the continuous azimuth measurements have limitations in themselves.
Yeah.
But it may be that you could automate on continuous azimuth. Right. So,
in other words, steer the line, so to speak.
Yeah, look at the continuous inclination, continuous azimuth, and use those as proxies. What I can share is what we've, one of the things that alerted us to this was that we saw gamma and inclination and azimuth all change at the same time. Once you had the depth log, and once you lined those, once you put those three traces against depth, you would see that they lined up on the same depths, and it appeared strange that inclination, azimuth, and gamma should all change at the same time.
Right.
Which got us thinking to this.
So those are trends that you could follow. And I guess a follow-up question to that, he's talking about directional trends, but have you given any thought to aligning the drilling mechanics, the shock vibration and so forth, and use that as sort of a signature to try to determine where you are?
Yes, I've given some thought in as much as as much as you just identified, is yes, the drilling mechanics may be the indicator. I haven't thought of it in depth, and I'm sure there's folk out there who are better able, and who are frankly just more intelligent than me, who would be better placed to make those suggestions. But yes, gamma, inclination, azimuth, and sure enough, vibrations tend to happen all at the same time. Now, the challenge with the vibration trace is that it also, or the various vibration modes, they also change at a different time. So
Right.
That one would need some further thought.
Right. Islam Mitwali says, thank you very much for an excellent presentation. If you have geomechanics on the pilot well and the horizontal, would it help fine tune the inclination hold mode on the new wells? That's sort of a follow up to what we were just discussing, isn't it?
I think so. I think what I would say is, the more information you have and the more information you can fold into the understanding of what you're trying to do, the better. I'm not sure if I answered Islam's question there, but yes.
Islam, if you need some more follow up, just go ahead and post another thing. Paul Pastusic, I've seen lots of system instability from control delays. What is the thought on how to make this stable? Do you need to feed in expected formation geometry?
Paul, that's a great question, and frankly, we don't know what we don't know. So I think you're quite right in identifying system instability as an issue, a potential issue. What I've outlined is a potential method. What I don't know is how unstable the system would be. I do think it would be unstable in some circumstances, and my suggestion in the conversation was that if you see instability, take it out of the enhanced hold inclination mode and put it into simple inclination hold mode. Not really satisfactory. My imagination is that as we developed, we would understand how to better control for the system instability. But frankly, I am not the best placed person to manage that one. I'm sure, Paul, that you are better placed. In fact,
that's probably why he asked the question.
Yes.
Paul, if you like, I can unmute you and you can ask this verbally or make some comments. So just raise your hand or put something in the chat and I can do that. Now, Pete, there's a warning here. It says Bill Lesso, but this is actually Ed Stockhausen masquerading as Bill Lesso.
Excellent.
Which you'll probably get the same question regardless, right? But so Ed, welcome to the show. Hope you're enjoying your retirement. So what sort of tool could be used to determine the walking tendency relative to a hard streak early? That's kind of a hard streak question, isn't it, Pete?
Yeah, it is. The forward looking. I may be arrogant enough to suggest this, because what you're trying to do is not intersect the hard streak. So you're trying to stay bed parallel, and my rampant imagination is that you would land this some way from the hard streak that you're imagining, that you would have a tolerance between where your landing lithology was and where the lithology that you're trying to avoid would be. So you give yourself a tolerance. As to if you get close to the hard streak, then I don't know what is going to find that for us, other than something that looked ahead of the bit, and I'm not sure that we're ready to jump into that one yet.
Yeah, there's if you look at these other questions, they're all similar, at least the next three. Islam Midwali had kind of a follow-up geosteering off of geomechanical model instead of lithology based geosteering, or lithology being the differences in gamma ray, right? And geomechanical being the vibration characteristics that we were discussing earlier.
Right. So I have a bad habit of saying things and letting my mouth run in front of my brain.
That's
so
one of those characteristics of being older, right, Pete?
Yeah. So one of the things I had thought would be a cool thing would be we have property models. We have property models for the reservoir. Wouldn't it be cool to have an MSE filled property model? So in some way have this three-dimensional model which described the energy that was required to drill the rock, and then navigate based off of the optimal drilling. So using the least energy for the fastest ROP. And again, with Paul Petusik in the conversation, I'm sure there's others who would be much better placed to think about that if it's even worthy of thought. But I think that's perhaps where Islam's going in the idea of some other form. I picked on geology because I picked on gamma because it's readily available and it's something that we're using day to day for geosteering anyway. So that's where this thought came from.
And Islam has a comment here that yes, we have seen good correlation between gamma ray and downhole shock and vibrations. So that formation response lining up with gamma ray. And to your point, Pete, I think if you can map that, build that roadmap of what that would look like, that gives you another reference point, doesn't it?
Yeah. Yes. Yeah.
I've heard geosteering described as trying to drive the fire truck from the back of the truck with blinders on, right? And all you can do is look to the sides and try to figure out where you are.
And another way of describing this is we've had open loop directional drilling. So, we make a survey measurement, it comes up hole. We have the directional driller make an intervention, and we drill ahead, and we then make a further measurement. I'm going to describe that as, to some extent, open loop. The tighter that loop, when we have drilling tools which are then acting on the measurement without the need for selective intervention, is an improvement. And if we can fold in the gamma ray measurement into that, then it might be that we're doing closed loop geosteering, and the closed loop directional drilling that we did hasn't reduced the number of directional drillers, and I'm not imagining that the closed loop geosteering would lessen the contribution of the geosteering community.
Right. Yeah, actually gives you a better control.
Yes, it would improve our focus on geosteering.
Yeah, absolutely. Paula says, your car analogy, we get to look ahead to see a curve coming. May not look ahead enough, but a good roadmap might help. And we've talked on pieces of this as well as having that roadmap.
Yes.
If you've not been down the road before, it helps to have a map of what's coming ahead, especially when there are curves in the road.
Yeah. So that's acknowledging that one. Yeah.
Jason Sanfilippo, Filippo. Okay. Hope I did that right. How would this technology and methodology working in heavily faulted areas? Would the algorithm be able to jump to match gamma that is outside of the target zone?
I'm going to be cheeky and answer this with I'm not sure how well it's going to work in unfaulted areas. Faulting it is going to make it more difficult and less likely to work. I am imagining because I've got a fevered imagination, I'm imagining that if it's faulted, then the lithology is essentially retained but offset, and it would be up to the operator to essentially re-find where they are in the lithology, and then go back to geosteering. So it may be that it's not simply put it into cruise control at the start of the lateral and forget it. If you got a number of faults to go across, you may have to navigate across each fault to get back into somewhere that you could put cruise control on. Yes, I don't. It's going to get more difficult.
Bill made a comment here that he didn't know Ed was that good on a computer to spoof him. Of course, that might be Bill imitating Ed, imitating Bill too. We don't know that for sure. I guess we'll just have to take it at face value. Greg Devenish, azimuthal bending moment would probably be the best mechanical measurement to indicate cause effect of course deviation. Mm-hmm. And there was a comment a little earlier, I think it was, unless I saw it. Talking about the effects that the BHA has and the instabilities, I think we've touched on that briefly, but maybe you could expand on that a little here.
Yeah, and so Greg's question, and thanks, Greg, and Martin's question after it as well, kind of talk to bending. I'm going to agree and modify at the same time. So yes, I think the nature of the formation push, as it tends to get characterized, is such that we're seeing fairly high dog legs. We're seeing dog legs of 5 degrees, 10 degrees per 100. So these are significant dog leg severity moments. The bending moment. So bending moment is great at picking that up. Absolutely. The challenge would be in an environment where the dog leg severities are smaller, and that's really the environment that you want to be in. You want to be in a situation where you don't see these bending moments. So yes, it probably is the best mechanical measure, but really it's one that you're trying to avoid having it appear at all.
Okay, Paul actually did raise his hand. I'm going to let him talk.
Hey guys, can you hear me?
There he is. Paul, that's a much younger picture of you. Either that or it's tremendously Photoshopped, one or the other, right? Pre-COVID, correct?
That's what I look like on a good day. How about that?
Okay.
Yeah, no, I was, I think everybody's been talking about stability issues on this control system. I mean, there's a couple of things. The delays, that is the worst problem with any control system, is having a delay. Of course, it is a foot-based delay. It's not time-based. If I'm drilling slow, I may have plenty of time to react. If I'm drilling fast, I may be overreacting or, that kind of thing. So you really have to know not only how far back you are, but you have to know how fast you're drilling in order to really make that system work, I think. Even then, of course, it's real easy to hunt, to go, bounce off the top and the bottom and the top and the bottom, something that we probably don't want to do. So.
Yeah, good point. Well made. Paul, I have to agree with you. It's in this imagined system. It's probably my biggest concern is the ability of the control system. That the only rejoinder I'll offer is I like the idea that this is something that could be tried for the cost of 2 downlinks. Well, it could be tried with a bit of development work, obviously. But it could be tried with the cost of two downlinks, one to put it into this mode and then another to take it out when you discover rapidly that it's not doing what you wish it to do. So
I would agree with you 100%, and you're right. If you you turn it on, it doesn't work, you turn it off. It's not like you've lost a lot. I will say that there's some good papers. One of them, it wasn't really on geosteering per se, but it was on the stability of directional. One of them, and it was the temporal delay or the foot-based delay from oh goodness, Schlumberger. Come on, I'm drawing the blank on the guy. Fix it.
I think I know of the gentleman you mean, but I can't.
Goodness gracious, somebody's gonna remember his name before I do. But anyway, he wrote a really good paper on differential delay equations. The thought that I had there is you can model it. I mean, you know, before you go and stick it in the ground and give me a wavy well, how about we model it and see what the control system feedback needs to look like.
So Paul, you actually bring up a very good point in that to some extent, this could be tested. This could be tested prior to any deployment. Yeah, there you go. I'm getting really starting to be more insistent on that sort of thing. You know, we talk about the analogy is let me wire a bunch of stuff together and plug it into an outlet, see if it smokes. And you know, and we kind of do that on BHAs. And we say, well, stick it in the ground and see what happens. Well, you know, we can model this stuff. We can get a lot better at it. Yeah. So obviously, if you use old data, what you're going to do is you're going to see what did happen, and not the intervention that you would have made. But it would give you some idea of what potential it has. Yeah, it's theory versus practice. You still got to do the practice as well. But Jeff Doughton was at Schlumberger, was who I was trying to. Nice. That's his paper, one of his many papers.
Okay, good. Paul, if you stay on. Marty Polk has a sort of a follow-up of the previous one about bending moment help with walking tendencies. And if you scroll down here a little bit, Jonathan makes a talk about or a point about deflections and having strain gauges to give the bending moment between the BHA and so forth. So you see several of these tie together here. Paul, I don't know if you can see the questions, but I think Pete can. I can. So I think what we're talking about is the characteristics, particularly from a bending standpoint, of the BHA itself. And any directional drill will be able to tell you that there's certain hole size, collar size configurations that are easier to steer than others. 6 3/4 with 4 3/4 collars. I mean, you might as well try to push a noodle down the hole, right? But some of these other things come in. So this all kind of ties together in sort of the flexibility / steerability of the BHA, particularly how it responds to these formation responses, these formation pushes that are coming into play. So that's all part of this this system approach that I think you're really talking about, Pete, that you have to take everything into consideration. I tried to combine all those questions together. I hope that was fairly clear. And for you, if you guys want to comment on that. Yeah, I don't have any specific comment other than to address one of the points that Jonathan Lightfoot brings up in terms of the collar stiffness. And for sure, if you stiffen up the collar, there's going to be less. As I'm sure Jonathan's well aware, if you stiffen up the collar, there's going to be less of a deflection.
Yeah, and I'm just going to add Gerald Heisig. He's over at Scientific now, but he was at Baker Hughes. Wrote a really good paper on dogleg severity versus instantaneous bending and being able to see the azimuthal bending. Is it, you know, you don't have to wait for anything else to show up. I know there's a Schlumberger paper, and I don't remember now who wrote that one. It might have been Richard Harmer, but he'll know who it was anyway. But there's a very similar paper by Schlumberger on azimuthal bending versus what shows up later as dogleg severity in the well. So
And just for grins, when I was with an alternative employer, I had a go at using the bending moment and translating that into dogleg severity and using the bending tool face and creating a well path position. It works. The challenge was if you went straight ahead, you got lost. As long as you were drilling a curve, you were great. You could get a reasonable match.
Yeah, that's a good point. Yeah, that's a really good point. Yeah, you still do. It's a supplementary measurement, not the only one you have, right?
Yeah. Yes.
I think that could be mitigated a little bit. Neuralis has come out with Neuralis and Gordon have come out with a system they call Gemini, which has multiple survey points. So with that, then you're having two independent surveys at some distance apart from which you can infer the curvature, right? It could be subtle, but you can infer the curvature. And I think to the point you were making earlier, Pete, is the problem is if you're just measuring something bending, you don't know which way it's bending necessarily. So you can have a bend or deflection within the collar, but if it's going left or right, you don't know. Well, then that doesn't really help you. It's a severity thing, but it doesn't really help.
Yeah.
But could some of these enhanced directional things help to tie in with the shape of the borehole and not just the degree of the curve?
Yeah, you need a bending tool face as well as a bending magnitude, a dogleg severity proxy.
Right. Right.
An interesting comment about dual accelerometers, because we did have a survey. I think Pathfinder had a survey tool in the past, which was based off of essentially chaining along two sets of accelerometers.
Yeah.
So
yeah. Well, that's the thing is there's there's a lot of these. I guess you could almost categorize them as niche technologies that have come and may be gone. Maybe some are even still available on a shelf somewhere in somebody's shop. But they never caught on broadly because I don't know that the benefits and the applications were actually well understood. And that can be a little bit of a challenge. But we have one more question left. And then if I can figure out something here, Ed Stockhausen said he had a model on his desk, which is a real surprise, right? That he would have a model on his desk. Even in retirement. So I can try to bring him on and allow him access. It wouldn't be bad to see Ed again anyway. So this last question here from Anon E. Mouse again. As a lie of automated geosteering, I'm not quite sure what he means here, but what can we do for geosteers to account for mechanical variables such as near-bit ink and near-bit azimuth behaviors and vibrations to update their model? And I think that kind of encompasses, again, a lot of the elements that we've described so far.
And I'm hoping that you're not going to direct that question at me.
Oh, that's a good Paul's question, don't you think?
Well, I'm going to deflect it because I don't know what the geosteering community can do because I'm not in that community.
Is that an intended pun? You're going to deflect that question?
Okay.
Paul, do you want to take a stab at that?
Yeah, I'll give you a real quick answer because I do have to run to another meeting and I apologize. But
okay.
The short answer is we can definitely see signatures and vibrations due to formation changes. I mean, and if you've been following any of this HFTO stuff, high frequency torsional oscillation, kind of the bit chatter kind of things, it shows up in really hard rock, and that's just gorgeous. I mean, it shows up real well. The vibration levels, and that's in the hundreds to 1,000 hertz kind of range. So, but could you use those things, including all the way up to 20,000 hertz, to kind of acoustic sound on the rock cutting process? The answer is yes, absolutely. There's some work that I did in a laboratory. We saw that acoustics emissions from a drill bit change when you drill different types of rock, and as well as different dysfunction. So yeah, I think you could use that clearly to help know what is the bit cutting as opposed to what you're sensing maybe. it may be. So anyway, yeah, I think that's a worthy area for sure. So.
Okay, good. Thanks for the contribution there.
Yeah, sorry guys, I do have to run, and we'll Pete, good to talk to you.
Thanks, Paul.
Thanks.
All right, see you guys.
Okay. All right, I have promoted one of the Bill Essos to panelist, and I don't know if it's the right one since they're cleverly disguised of each other. This is actually starting to make me wonder if Bill and Ed were actually interchangeable. Back in the day when they worked so close together. They may have just been changing bodies, you know, going back and forth. So,
can you hear me?
Is that you, Ed?
That's me.
Oh, I picked the right one. Holy cow, I had a 50%.
I should be Bill too, or something, or Little Bill, or something. I don't know.
Just go ahead.
I don't know if the video, you know, if I could actually, if my, whatever you call it, the camera, you know, is turned on or whatever. As far as being able to see from my monitor.
You have to turn the video on.
So there's start video. I don't want to.
Down there you go.
There we go.
Oh, it actually is it. It's not Bill.
Not bad. You got to get a haircut. My COVID hair is getting kind of long here, but it's.
Well, at least you don't have a.
I have hair. No, we won't talk about that. All right, so let's see if we can turn this thing down to the model here. So here's a bed.
We're glad you're wearing pants too, Ed.
Yeah, I got pants on. I got a bed, and we got a rotation. Hopefully now we got a rotating bed, and it's drilling down and hits the high strike. It goes to the right, so it goes the right way, right?
Oh, cool.
Our part is trying to do it the opposite way and hitting the high street on the bottom without cheating. So it comes up here from the bottom. See how it goes. Oh, so you just need to play with, you know, does it go to the right or the left? So I proved your point. Pete, you're correct. Anyhow.
Ed, good to see you again, and thanks for that. It's a great visual.
I'll have to share one of these. I was supposed to make these in my retirement. I was going to make little models and send them to people like Pete, and so they could just have toys, you know. Okay.
I'll tell you what, Ed, we'll put an ad up on the IDD website. You know, models. You know,
models for sale.
Drilling models made by a long-haired geologist.
I'm gonna get a haircut. Well, I may get a haircut today, but we'll see.
Yeah.
All right.
Well, if we can take up a collection for you if you like, you know, we'll send you the money so you can go.
If I stand in front of the light here, it looks like I got a halo, you know. So, gotta work on that.
Excuse me, you're getting me all choked up.
We'll come over this one. All right. Anyhow.
Pete, if I can get it out, we have one more question. I ran out of water. If I'd have known Ed was going to be on, I definitely would have filled up before I got started. Wire drill pipe to get depth down to the RSS for ROP would help a lot, so as to not get totally lost.
Yeah.
And I'll bet you Darren works at Intellisor. What do you think?
So the answer, that one has a really simple answer in that being able to send data both ways. Yeah, I mean that's going to be great. It's the question would always be one of cost.
Yeah,
those systems have tended to be cost prohibitive so far. So perhaps one day.
Well, and I think that falls in the category, Pete, of what we were talking about a few moments ago. Was the there's a lot of technologies out there that you know have not found a broad application. And the wired pipe certainly can be. I mean, you know, that was always described as like drinking data out of a fire hose, you know, and I don't think a lot of people actually knew what to do with it. You know, I think years later, I think we have a little better appreciation and understanding, but, you know, is it something that could be implemented on a broad scale? That would be the question.
Yep.
Well, good. Well, if we don't have any other questions, I'll give everybody a moment to do that. I'll talk for just a minute about, oh heck, I've got all kinds of stuff up here, but we actually, I don't know if you heard us talking earlier with Pete about some of the social things and folks getting out a little bit. We actually are having a happy hour this evening at the Butler House. It's off of Gosling Road in up near the Woodlands. So you can just go to the website for the information for that. We have a couple of sponsors for that. I should have that in front of me, but it's Wolverine and Tally and Arrival Oil Tools and so forth. So, you know, we certainly recognize that not everybody is comfortable with going out or is able to go out. But if you are, it will be a bit brisk tonight. So I would encourage you to bundle up. I think most of us are digging into here in Houston are digging into the closet for clothes that we haven't worn for quite some time. So it's going to be a cool weekend. And then next week we have a mud motor training class. In fact, let me go ahead and I can pull this up and switch it. Here we go. So we have mud motor training class that Dr. Samuel is teaching on the 17th. Then the mud motor webinar is going to be on Thursday, the 18th. And then we have our Sweetheart Sporting Clays tournament is on the 19th. So you see we have a busy week next week. And then the following week is our chili cook-off. So you see we're having a match or a blend of some social events and instructional events and training. So that's what we're attempting to do with everything. So Ed, be careful you don't hit yourself in the head with that. But yep, you know, you see the glint in his eye when he does that. You know, that's the scary thing. But Pete, want to thank you very much for your contribution here today. One last question. I actually thought about this earlier, but are you actively taking steps to get this implemented?
I will be now.
Yeah. Okay. So the cat's out of the bag now. So
the cat's out of the bag, and we'll see where we can get to with this.
Well, I'm not surprised. I happened to see that there were several MWD company representatives and Rotary Steerable company representatives online. So I'm sure they were watching with keen interest.
Yeah.
I'm surprised nobody raised their hand and said, look, send me, send me.
And it may be that others have better ideas, and that would be great to hear as well. So.
Well, you know what? It may not be bad to have a forum, Pete, kind of a follow-up, to have a discussion, you know, to get guys like Paul and, you know, George and heck, we might even pull Ed out of retirement again to get his contributions. You know, I'm sure he's had time to gestate on a lot of these stuff, but, you know, I'd suggest that we look at a follow-up here in the next 4 to 6 weeks or so and have a discussion about it.
Yeah, well, I think it's going to be a longer. It would have a longer gestation than that, but yeah,
4 to 6 months maybe,
or years.
Well, hopefully it's not that long.
hopefully at some point.
Yeah, well, no, I understand. All right, everybody. Well, thanks so much for your participation today. And this will be up on YouTube here probably in the next 20 minutes or so. So you can go back and review it. And with that, everybody stay warm and have a